Whoa, why does jasmine rice keep falling apart?
Yo, you want to see my sticky rice? But it's sticky. Why?
They're both rice, but they are completely different.
The answer is actually chemistry. Even though sticky rice and jasmine rice may look similar, they contain different type of starch molecule that changes their texture when cooked.
Rice starch is made of two important molecules, amylose and amylopectin.
Sticky rice contains a high amount of amylopectin and very little amylose. Amylopectin has a branched structure that traps water and allows the rice grains to stick together easily.
Jasmine rice contains more amylose. Amylose have a straighter structure, which helps keep the grains separated instead of clumping together.
You can think of amylopectin like tangled string that easily connects together. Amylose is more like straight spaghetti strand that separates more easily.
To compare the two, we cooked both types of rice using the same amount of water. The sticky rice formed clumps and held its shape easily. Meanwhile, the jasmine rice stayed fluffy and separate.
However, starch composition is not the only factor that affects texture. Water amount, cooking temperature, and cooking methods can also change the final texture of rice.
This difference is important in cooking and food culture. Sticky rice is often used in dessert and dishes that require sticky texture. Jasmine rice is preferred for meals where separated grain are desired. Now let's dive deeper into the chemistry. We've mentioned before that rice contains starch, which is mainly made out of two molecules called amylose and amylopectin.
Even though both molecules are made from glucose units, they have different structures, which changes the way rice behaves when cooked.
The main functional group in both molecules is the hydroxide group, also known as the HO group.
These hydroxyl groups are polar, meaning they can form hydrogen bonds with water. Because of this, rice can absorb water and soften during cooking.
One starch molecule has a mostly straight structure, allowing the chains to pack together closely. This keeps the grain firmer and more separated after cooking.
The other molecule has a branched structure, which traps more water and increases interaction between molecules. And this makes the rice softer and stickier.
When rice is heated in water, the hydrogen bonds inside the starch begin to weaken. Water enters the starch granules, causing them to swell in a process called gelatinization.
So overall, the texture of the rice comes from the molecular structure of the starch and the way the hydroxyl group interact with water through hydrogen bonding.
Now let's go to the fun part. Fun fact, sticky rice has been eaten in Southeast Asia for over thousands of years.
It is especially popular in countries like Thailand and Laos, where it is an important part of traditional meals and desserts.
Jasmine rice originated in Thailand about a few hundred years ago, mainly grown in the Central Plains. It became globally important in the 20th century due to export demand.
While sticky rice has a much older history, dating back over 4,000 years in regions like Laos and northern Thailand.
And did you guys know that amylose and amylopectin were identified in early 1900s by Thomas J. Strauch, is credited with separating and defining them in the 1940s.
In the past, people carried sticky rice in small bamboo containers because it was so easy to eat by hand.
Sticky rice is usually steamed instead of boiled, which help it keep its soft and chewy texture.
This shows how food, culture, and chemistry are all connected.
Oh, the difference between sticky rice and jasmine rice comes from their starch chemistry.
Yes, that's why sticky rice contains more amylopectin, making it sticky, while jasmine rice contains more amylose, which makes it fluffy and separate.
This is how chemistry explains the food we eat.
Everything said in this video has been based on this poster right here that we have all made together. And thank you for watching.